Hi children, good evening all of you. Today we will learn the second chapter in our chemistry, that is nature of matter. We shall try to study this and see what are the topics that which we are going to cover in this nature of matter. Number 1 is states of matter, 2 nature of matter, interconversion of states of matter, elements and compounds, modern concepts of an atom, conceptual questions, real life examples, chemical formulas, changes around us, reversible and irreversible changes. At the end, few questions we are going to study. See now, before going to start our topic, we shall start the concept with the help of an activity so that you can understand clearly, children. See now, tie an empty can to a spring balance. You just take a spring balance first and tie an empty can to it. Okay, and record its weight. You can do it by yourself, children, this one. Record its weight in your laboratory or whatsoever. With the help of the teacher, we can do it easily. You can do it. You weigh the can of empty can. Then what you have to do? Fill the empty can completely with water and record the second weight. The first weight is empty can weight. Then fill completely with water and again weigh it through spring balance. It will show you some reading. Or else you can take a can and put, if you have digital board or weighing machine whatsoever, you can put an empty can there, and second time you can put fill it with water. Second time you can go that. Then afterwards you take sand in an empty can and try its weight. 3 times you have to take weight. First one empty can weight, number 2 weight of the water, number 3 weight of the sand. What you can observe? You can observe that water and solids in the sense here we have taken sand, has weight and hence mass. Generally, when compared to the empty can weight, the can which is filled with water and the can which is filled with sand will have more weight. So from this we can conclude that solids and liquids have weight and mass. And one more thing, sand will have more weight compared to water. So from this we can conclude that solid will have much weight when compared to liquid. Next we go for another type of investigation. The second one, take 2 inflated balloons. Inflated balloons అంటే బాగా ఊదిన బెలూన్స్ అన్నమాట. ఆ రెండు ఏం చేస్తా, ట్రై ద 2 ends ఆఫ్ ఇట్, హాఫ్ మీటర్ స్కేల్ తీసుకోండి. రెండు వైపులా ఆ ఇన్ఫ్లేటెడ్ బెలూన్ అనేది టై చేయండి. యూ ట్రై టు టై ఇట్ అండ్ బ్యాలెన్స్ ఇట్ ఆన్ ఏ నైఫ్ ఎడ్జ్. ఒక షార్ప్ ఎడ్జ్ పైన దాన్ని బ్యాలెన్స్ చేయండి. ఎందుకో రెండు ఊదింతాం కాబట్టి అది బ్యాలెన్స్ అవుతుంది. హీట్ ద నీడిల్ అంటిల్ ఇట్ రెడ్ హాట్ అండ్ కేర్ఫుల్లీ ప్రిక్ ద బెలూన్ ఆన్ ద రైట్ సైడ్. ఒక నీడిల్ తీసుకోండి, యూ టేక్ ఎ నీడిల్ అండ్ హీట్ ఇట్ అప్ టు it becomes red hot. Okay, then you just try to touch the balloon so that it will blast. What happens? The scale tips down to the left. The scale will shift to left. It has burst and it will shift to left side, and as the right balloon is lighter now. ఇది పగిలిపోయి ఉంటుంది కాబట్టి ఎడం వైపుకి వంగిపోతుంది. దీని నుంచి మనకి ఏం అబ్జర్వ్ చేయొచ్చు? వాట్ వీ కెన్ అబ్జర్వ్? యాక్చువల్లీ వాట్ ఈస్ ఫిల్డ్ ఇన్ ద బెలూన్? ఎయిర్. సో ఎయిర్ విల్ హ్యావ్ వెయిట్ అండ్ మాస్. ద బెలూన్ ఫిల్డ్ విత్ ఎయిర్ ఈజ్ హెవియర్. స్టార్టింగ్ రెండు బెలూన్లోనూ సేమ్ ఎయిర్ ఉండింది. ఎప్పుడైతే ఒక బెలూన్ని తూటు పెట్టేశామో ఏమైంది? ఇంకో బెలూన్ మాత్రమే ఎయిర్ అనేది ఎక్కువ ఉంది కాబట్టి అటువైపు వంగుతుందన్నమాట. సో దాని నుంచి మనం ఏం చెప్పచ్చు? ఎయిర్ కూడా, ఈవెన్ ఎయిర్ విల్ హ్యావ్ సమ్ సార్ట్ ఆఫ్ వెయిట్, వీ కెన్ సే దట్. We go for one more investigation. Take a glass tumbler and place it in a bowl. We have taken a glass tumbler and we just place an empty glass tumbler in the bowl. Pour water gently in the tumbler so that it completely fill. ఏం చేయాలి? వాటర్ కంప్లీట్గా ఫిల్ అయ్యేటట్టు నీళ్ళు పోయాలి దేంట్లో గ్లాస్లో ఇన్ గ్లాస్ యూ హ్యావ్ టు pour. Tie a small stone to the thread. Lower the stone gently into the water in the glass tumbler. We have taken glass and we have put it in the bowl and we have completely filled the glass with water. Then we took thread and we have tied some thoughts of stone to the thread to the stone, and slowly gently we are going to dip the stone in water. What happens? Water overflow from the glass tumbler into the bowl. Water అనేది ఎప్పుడైతే మనం అది వేసామో వాటర్ ఓవర్ఫ్లో అవుతుంది అనమాట. వాటర్ విల్ ఓవర్ఫ్లో టు ద బౌల్. Then from this what we can conclude? Solids and liquids occupy space because one solid is coming in instead of liquid, so that much amount of space is going to be poured out in the tumbler and it will be poured into the vessel or bowl, and hence push the water out of the tumbler. The water occupies space as well. So from this we can conclude that water will also occupy space. So this is the investigation. From the above all investigations we can conclude that all material bodies will have weight and have hence mass. All material body occupies space. So two things, all bodies will have mass and all bodies will occupy space. So any material which has mass and occupies space is called matter. So this is the definition of matter. So what is the definition of matter? Anything which occupies space and have some mass is called matter. Next we go for states of matter. What are the states of matter? Matter is going to be existed in 3 states. Actually 4 states. We will discuss the 4th state later. Okay, solid, liquid and gas. The 4th state we call it as plasma state. Remember children. So solids, the substances like wood, stone, sand and iron are called solids. Liquids means substances like water, juice, milk, etc. Alcohol, okay, fruit juice will be called as liquids. And gases, substances like oxygen, nitrogen, helium, carbon dioxide, steam are considered as gases. Properties of solids. See children, you have to listen carefully so that you can understand the things. These are very basic concepts you should kept in mind. So listen carefully. What are the properties of solid? The first property is solid have definite shape. What is the first property? Solid will have definite volume. So it is having some particular shape. Shape in the sense it may be regular shape or irregular shape whatsoever. It will have some volume in the sense it will occupy some sort of space. So it is called as it is having some definite volume. Fixed volume. Definite or we can say fixed. We can use any word. Both are same. Fixed and definite. Solid do not flow. They can be heaped. Heaped అంటే కుప్ప వేయడం అనమాట, కుప్ప. సో వీ కెన్ పుట్ 1 by 1 ఇలా కుప్ప వేసేదాన్ని హీపింగ్ అంటారు. దే కెన్ బి హీప్డ్. సాలిడ్ డు నాట్ నీడ్ ఏ కంటైనర్ టు హోల్డ్ దెమ్. ఇన్ ఆర్డర్ టు హోల్డ్ ఏ కంటైనర్, సో దిస్ ఈజ్ ఎ సాలిడ్ పెన్, వీ కెన్ హోల్డ్ ఇట్ ఇన్ హ్యాండ్. If it is liquid or milk whatsoever, you cannot hold it in hand milk. We need some container, either bottle, can or glass whatsoever. We need, that is called container, vessel whatsoever. So in order to pour liquid, in order to hold the liquid, we need container. In order to hold a solid, container is not necessary. A solid, what is the definition of solid? A solid is a material which has definite shape, definite volume and can have any number of free surfaces. What is the meaning of free surface? See here, there is a table here or there is a pen here in my hand. I am holding this pen. Around this complete area there is a free surface. In the sense solid doesn't pour or solid doesn't escape like gas. Okay, so it is called a free surface. Okay, so solid will not escape. That region we call it as, that is why we are calling it as free surface. Right. Next one, we go for one of the investigation in order to explain the liquid now. So take a water in a cup. We have taken in the first step, right? It takes the shape of the cup with one free surface at the top. So if you pour water in a cup, the water will have a shape of a cup. If you take the same water in a bowl, the water takes the shape of a bowl. If you take the same water in some flask, it will take the shape of the flask. So the water does not have any particular space. Pour water from the cup into the bowl, the water flows. Water will flow. Okay, water will flow and takes the shape of the bowl with one free surface at the top. Top surface is the free surface. Pour water from the bowl into the flask. From cup to bowl, bowl to flask. What is happening? Water flows and takes the shape of the flask. When we took the water in cup, water has taken the cup shape. When the same water has been poured into the bowl, it took bowl shape. The same water has been poured into the flask, it took the flask shape. So it does not have particular shape. It is taking the shape of the container that which we are taking. Right. So in every concept there is one free surface on the top. Okay. Right. So from this what we can observe? We can observe that liquid takes the shape of a container. Not only water, any liquid you consider, it will take the shape of a container. Liquid have one free surface that will be at the top. At the top there is a free surface. Free surface is one where it does not escapes, though it is free. That is called free surface. Remember children, solid will have, see this pen, whole complete space around it. There will be infinite number of spaces for solid. Liquid will have only one free surface because in all the other sides it has been bounded to the what? Container. Alright. Next we go for some liquid do not get compressed. See now. There will be the compression for the liquid that will be very negligible. Generally they won't compress. We can prove it. How? Take a syringe and fill completely with water. First you take syringe, you just stretch it and you try to fill completely with water. We have filled. Cover the nozzle of the syringe tightly with a thumb. With this nozzle, this is what, this is nozzle, okay. You cover tightly with the thumb or you put some closed thing. Okay, you close some rubber stopper with stopper or whatsoever. Then what happens? Push the plunger hard inward to the pressurize the water. After closing this, you try to push hard to compress. So what will happen? You will observe that the plunger does not move downward. Okay, since we are having water here, the plunger will not move down. So from this we can conclude that liquid do not get compressed. Okay, from this we can observe that liquid will not get compressed. Their volume remains same even under the compressive forces. Volume will not change. Liquid does not get compressed. From this we can conclude. Next we go for the conclusion from the above investigation. Liquid have no definite shape. They take the shape of a container, and liquid have definite volume. It is having definite volume but doesn't have definite shape. Remember, the volume in the sense the container which shape is nothing but volume there. Liquid always needs some container, otherwise they start flowing. They will not stay, they will start flowing. Liquid have only one definite free surface, that is at the top, we already discussed, in which they are contained. Liquid cannot be compressed, their volume does not change. So likewise we can say. And next one, we go for one more investigation to explain the property of gases. Take different shapes of balloons and fill air inside it. Okay, the air inside the balloon will take the shape of the balloon. If it is heart shape, it will take, if you fill the balloon, it will take heart shape. If it is some other shape it will take the spin. Similarly, if it is sphere, it will take sphere shape. It will be some cylindrical, it will take cylindrical shape. Likewise. So air does not have any shape and it will take the shape of a container that which it is filled. There is one more activity. Air or gases we can say. Gases have no definite volume even. At least liquid will have definite volume. It is having a volume of container, but it doesn't have even a volume. See how we can prove it. Take an empty glass bottle and pour into it a few drops of scent. First we take an empty glass bottle like this. In that you pour some few drops of scent. Smell the bottle. You will be able to smell the scent. Now place this bottle in your drawing room open and leave it undisturbed for few minutes. What happens? That scent will be spread all over the room. Okay. So from this what we can conclude? We can conclude that gases have no definite volume. They have the property to fill the entire space available in the room. If there is very small amount of gas, it will spread all over the room. Even the gas which has spread all over the room can be fit in small box, okay, matchbox even. So gases can be compressed as much as possible. Even they will diffuse. That is called diffusion. In forthcoming classes, you are going to learn what is diffusion. Like that, they are going to be expand to a greater extent. How much they have area. Okay, so this is the thing. Next we go for take a disposal syringe and remove the plunger. You just remove the plunger and seal the nozzle with Fevicol. You just seal the nozzle here. Okay, allow the Fevicol to dry, then replace the plunger and push it inward. Okay, so when you pluck it and after that you can push it. Though there is air inside, if you pluck it, the air is going to be filled in that. After that you just close it. Then you push it. So what happens? It will move. In case of liquids it doesn't move, but in case of gases it moves. What does it indicate? It indicates that the gases can get compressed. Okay, gases can be compressed. Gases get compressed when force is applied. They return to their original volume when the force is removed. When once again if it comes back, the gases will expand and fill all over the syringe. Okay, so from this we can conclude that the gases can be compressed. At the end, the conclusion is, from the above investigation we can say that the gases will have following properties. Gases does not have definite shape. They just take the shape of a container or a vessel. Okay, that doesn't have definite volume. They have the property to fill the entire space which is available. If it is very small space, it will adjust in very small space. If it is a very huge space, the gas will expand and will spread all over that particular space. Gases can be compressed and they have no free surface. So likewise we can differentiate solid, liquid and gases. Thank you children. Bye. We shall meet in the next class.